everyone. Welcome to SREday on a Saturday. And I hope I don't make you sleep after a heavy lunch. And thank you, team, for inviting me here. My name is Kaustubha, and I work at Microsoft. I'm a solution architect there. So I work with teams with cloud, automations, and AI-related architectures where I'll be helping them to scale across and also make sure that they're reliable. Let's see some of the landmines that we observe when we have our applications in Kubernetes. So what is the promise of Kubernetes? It's scalable, right? Like it's scalable until it starts breaking. So you need to have some measures which will help you understand or detect what is happening in your Kubernetes cluster. It is always scalable and things happen in a very easy way. So you will have to have some of the observabilities and other things which have to be integrated into your Kubernetes environment. So in one of the surveys, we saw that 70% of the errors in Kubernetes is because of the configurations and the misconfigurations which have been done by humans. And it is not the problem of the infrastructure. So most of the problems come, maybe there is a missing colon or there is extra 2 spaces in YAML. So that could be the reason of one of the outages where you could see Slack coming up every 2 a.m. at midnight and saying that there is logins which have been failing continuously. So some of the things happen just because of misconfigurations, and there are also some of the security mistakes which are causing all of this. So let's see what are those today. So we see outages happening, right? Like we see a lot of articles being written across, and we see that people saying that there was a big outage and many users were affected because of it. So even though there are so many things happening, why is it being repeatable? So there are 4 things here. If you just see the screen here, the first thing is the configuration drift. So Kubernetes is like a self-driving car. So it can drive on its own, but you need to have an updated map. So if your map is not updated, there is no point of having a self-driving car, right? Like it needs to know that there are certain things or constructions happening at one part of the place so that it can give you a rerouted route for the place you're trying to go. So that is what is happening. So there are so many things which will be happened in the production workspace, and you would have seen the configuration drift happen, but your like source control and the teams will not be known of it, and only manual fixes will be happening. That is one of the major problem with the outages that happen. The next one is human error, YAML. Yeah, YAML is very powerful. At the same time, we could see like a lot of issues happening when you're missing either semicolons or there are some spaces which has happened. Like I read an article, I think there was a big outage because they had used the CPU resource utilization for pods. Like it was 100, it had to be 100, but it was by mistake written as 1000. So every time a new pod had to be created, the scheduler thought that the resources are not enough and it stopped creating pods. So it was small error in the YAML file, but caused a huge amount of problems for the production related environment. Such typos or indentation mistakes or incorrect values, these are some of the challenges which we will have to check. And I see that there is a lot of lack of validation that is happening. There is no proper policies to check all of this, or there is no proper policies applied to see like what are the changes happening. So that is the another problem why there are outages being repeated. So the other thing is the culture. So we see that people are firefighting, like when there is an issue, when there is an on-call, and when there is a P1 incident happening, people jump in. People come in to see that they'll be able to resolve it. But there is no proactive thing which is happening. Like, why is there an outage in the first place? So there has to be retrospectives happening after a P1s. So we see that things are being changed across and it doesn't repeat itself. That's one of the things we will have to do. So the other other landmine which I see is on the security side. So most of the important things here are like people try to give root access for all the pods. So thinking that is easy thing to do and easy thing to maintain. I can give one of the example of an article which I went across. So an intern who started writing some production related code had written root access for all of one of the containers, but within an hour, we could see that all of the monitoring agents had deployed pods with root access. So it is a small mistake, but they didn't have any policies to check across. Maybe they need to have something like Trivy, or they need to have something on the Falco network rules, which will be able to check across and notify them and not be able to send or push that code into the production. That should be the level of checking that should be done before the code is in the production. So the next one is on the vulnerable base images. So there are a lot of images which have been pushed into the production without having the right amount of scanning done to see what are the security issues. It could be some of the places where the vulnerabilities are not being detected or it has not been taken into consideration, but they started pushing the code or the image of that into the containers and that's been into the deployment. So I think we need to have scanning of images and we need to monitor the runtime of those. And the other problem which I could see in this, there is a lot of issues with the permissions given. Overly permissions are given for, they're not taking into consideration what is the things which is required versus what are the generalized things people are, they take into consideration that these are the generalized things necessary and just do it. But they don't think that they're giving overly permissions for all of the resources which are being deployed. So we need to have something like least privileges given across. We need to make sure that only the necessary permissions are given and the things which might not feel like needed for that pod or for that application should be avoided. So the other landmine which I could see across is like the configuration catastrophes. Like we could see, as I told, there was a problem with the YAML file where the resources required was wrongly specified. So pods get out of memory and they get killed across because some of the misconfigurations in the YAML, or it could be like misaligned requests or limits given across. When they are specifying in the YAML what are the resources required, like when you want to spin up any resource, like it could be pods, through the containers, you will have to specify what is the limit and what is the request for the CPU and memory. So there will be people who would be specifying those things wrong and there could be issues because of that. And copy-paste manifest. People try to develop things by copying what is already existing without understanding what is the reason for having those in the first place. That could be one of the problems. And there are no policies to make sure that guardrails are available to check and see if this is a really necessary configuration to be pushed across or is this dangerous? Should this be in the production at the first place? So some of the solution which we could solve is have admission controllers. This could be the gatekeepers, like which you can have in your production environment where it will keep validating and mutate the objects based on the request. It is not just creating things, it's always validating things before executing them. The next thing is, like I think the previous session where you all attended, they explained very well on the GitOps pipelines. I don't want to go back to it. And the other thing is, like when you see that there is no analysis for configurations or to catch misconfigurations, you could use some tools called kubelinter. So it catches some of the misconfigurations in your kube files. So there are some of the blind spots which I thought to share today. So the first blind spot is limited metrics. We see that most of the organizations which try to develop things into the production always think about few metrics, like what is CPU utilization or what is the memory utilization. So these are not only the necessary metrics, but this will tell you why, what happened, like what was the increase in the memory or what was the increase in the CPU. But you will have to know, go deep into it, like why did it happen in the first place? Why did the CPU or memory increase? That should be the level of troubleshooting we all should be doing. The next thing is like missing runtime visibility, like people will be seeing on the top level, not going inside the kernel level. We will have to go through some of the eBPF logs and see what is the kernel thing happening inside, which are causing all of those events. And logging noise. So there is a lot of unstructured logs which bury the real information required. There is no any proper dashboards like which is visible on the production level environments which will help us or understand what is happening. So some of the paths which we could take to solve the above blind spots which you spoke would be like we could use some of the open telemetry, like where we'll be getting the logs aggregated very fast and we'll be able to understand what is happening. The next is like what I already mentioned, eBPF observability, where we will need to go have the kernel level visibility to understand or troubleshoot the issues. And to reduce the logging noise, I think we need to have Grafana dashboards and SLIs and SLOs to make sure you tie the service level objectives into whatever happening on the production side. So it will build you alerts and it will give you some metrics which will help you tie up between your SLI and what is happening in your system. So the other landmine I want to discuss today is on the scaling traps. Like we could see that Kubernetes is used only for scaling. People want to use Kubernetes because it is auto-scaling. There is horizontal pod autoscaler, HPA, like which auto-scales and it drastically increases or decreases down based on the availability. So that could also be one of the problems, like it is not creating stability. That could be one of the issues, like creating instability because of certain things happening in the production and we are not noticing it. We are just thinking that our application is not down. But internally, when you see that there is a lot of cost happening because of increasing or decreasing of all these resources, even for a little period of time. So the uneven node scheduling is another one which is reducing the performance in the Kubernetes application. It could be like the pods are clustered only on certain related nodes and it is sitting idle, other nodes are sitting idle and they're not utilized fully. That could be one of the reasons for reduced performance. And we have something called as reactive lag, like where the scaling decisions are based on something called as like current load to arrive, not on what is already happening there. So this will cause the reduction in the user experience. And also like during the traffic spikes, you could see that the users are not getting or able to access the applications as frequently as they could. So this is because the scaling is always dependent on what will happen next, like not on what is happening right now. That could also be degrading your performance of the application. So we can have some smart scaling strategies like I've mentioned below. Like we can have vertical pod autoscaler instead of horizontal. Sometimes like right size of resources based on the actual usage patterns could help us reducing the cost also. It's not like always having horizontal scaling is necessary. Sometimes when you get to know your system better, maybe you can have something called as vertical autoscalers where the right type of resources for you can be utilized. If you think in Azure, we have something called DS series missions, and we also have something called as HX series missions, like what the other session people spoke about the runners, right? Like same way. So HX is for high performance, but it is little costly. But DS series is for missions which are of little low performance and the cost is also less. So you will have to understand having 100 of DS or 10 of HX, what is the cost and what are things happening. So those type of performance benchmarking needs to be done. So then instead of uneven node scheduling, we need to do predictive scaling, like where we can use the historical data from all of the dashboards which we built across to scale across. And also we could have something called as custom metrics, where you can see the request latency and other details there. So after going all of this process, now what is AIOps? AIOps is where we'll be using the machine learning and it will be analyzing our system and helping us and also augment and make our life little easier, so that it is like a private detective for us who will be running every day, every night, every second, and make sure that we are being informed before something happens. It's a proactive way of monitoring your environment. So what does it do? It could do anomaly detection, where it could see like some of the deviations that are happening inside a system, like before even we detect it. Other thing is like it could do auto triage patterns, where it can correlate the signals, prioritize them, and make sure that we are informed on the critical issues, like what could happen in 15 days if you are not taking care of this type of an issue. It could be proactively informing you on what is happening on your application side. And also it can give you the root cause suggestions. Like it could take the historical data which is unstructured from your side, and it can make sure that it gives some metrics out of it and help you understand like what is happening in your system. So the other thing which is missing here in some of the production environments which I went across is like they don't have something called hardening checklist. So you need to have something like this in your Kubernetes environment, which will help you make sure that it is like a guardrail and help most of the incidents or most of the problems which arise using Kubernetes are solved when you try to follow those things. Like there are 3 different parts in it. The first thing is on the security side, where you need to make sure that only signed container images which are vulnerability free and always using the latest ones should be made sure it is like a compulsory thing to be done in your org. The second thing is like all the users must be non-root when they are trying to signing into the system. And also like you need to have network policy enforcements, like it could be anything like network policies using the Kubernetes, or if you have any other type of like Kyverno or other type of network policy things, you can utilize those. The next part is on the reliability side, where you need to make sure like what are the resources requests required and what are the limits for those resources you need to set it up. And also you want to make sure that liveliness and readiness probes are always enabled in your YAML files. And also you need to have something called as pod disruption budgets, which will help you understand like what level of reliability you can have in your system. So the third important part is like on the observability side, where you'll be using the structured logging instead of having unstructured logging, where you'll have to dig deep into every time you get an P1 incident in your on-call day. And also you have something called as golden metrics, where you will be dividing this into 3 parts, where you'll be taking care into the logs, metrics and traces, which will help you understand more into what is happening in your system. Logs will tell you what happened, traces will tell you where it happened, metrics will tell you when it happened. So this is how you'll be understanding your system. The next thing is on the distributed traces, where you'll be trying to understand what is the visibility happening in your system. So these are all the 3 pillars which you'll be utilizing to make sure your environment is production ready. So we need to make sure that you automate the prevention and you're not just taking the responses for happening. We being SRE engineers doesn't mean like we need to be always on call and understand what is happening. We need to make sure that doesn't happen again. So that is one of the things which we need to take care. So we could use something called as the continuous compliance, where the policies are always enforced and every deployment using some of the tools like which we already discussed. We could use the drift detections, where you could see like you can have a live state, and when it is drifting apart, you can be notified across and see what is happening in your system. You could do some chaos experiments. Like this is one of the good thing which I learned across. I think Netflix uses this. This term has been coined by Netflix, chaos testing. It's like where a person goes randomly into a production environment and destroys something, and they're going to test what is the level of reliability the system has. So what happens if something is not working suddenly? Instead of really happening, they do it purposely. So the below ones are some of the essential tools mentioned, like Argo CD could be utilized for the GitOps, and policy controllers to have organizational standards, and litmus testing to do some of the chaos experiment. So the goal here is to not build the perfect system. It is like to build systems that fail gracefully and also come back automatically, not having the human intervention much. So what are the lessons which we learned across here? So we understood that reliability is instrumentation, like we need to build it, and post-mortem loops are like utilized for improvement rather than blaming others what happened when they were on call. So we need to make sure that the post-mortems are blameless and everybody has a visibility to talk across what is happening in the system, find the loopholes instead of blaming the person like who didn't respond, who was the person at that on call when this happened. So we need to make sure we develop blameless culture. So the next thing is like we could utilize ML-driven anomaly detections, where the mean time to recovery is reduced by 40%. So this could be like one of the great things to do, because in one of the projects we implemented in Microsoft, if you could see like when we did ML-driven anomaly detection, we could see some of the incidents being reduced and also the MTTR being reduced by very drastically. So we utilize some of the ML algorithms to see what are the issues happening across before they even occurred. So that is one of the things. So the closing thoughts here is reliability is a mixture of security, observability, and the culture which we need to develop. And also we need to make failures routines before disasters. Have chaos testings in your environment. Go randomly destroy something and see how is the team reacting to it. How are the resources reacting to it? What is happening there? And also we will have to shift our culture from being reactive to proactive. It is not like having a firefighter type of a culture where something happens, everybody gets together and solves it. So we will have to be proactive before something even happens. We'll have to make sure we are being told or informed on it. This could happen within 15 days if you're not taking care. I could give an example on this. Like for example, we had one AI project which I took up. So they wanted to make sure they're notified when one of the nodes fails. Like before even the node fails, at least like a month before. So we had to go through all of the logs, build an ML algorithm for it, and we could see some of the patterns in the nodes which were failing. So we could utilize those patterns and make sure that other nodes which are having same patterns being repeated are getting notified even before the failure of the nodes. So that is how you could utilize ML algorithms. So that's the presentation I had for today, and thank you so much. If you have any questions, you can shoot it across.
HPA and VPA, you said we could face instability when we use HPA.
So normally people prefer to use horizontal autoscaler. Like whenever there are missions, they want to spin same type of missions, couple of different types of missions. But vertical scaling is where you'll do it once you know or get to know about your environment. Like I know that this is the right mission to put across. If I'm doing on a smaller scale of a mission and I understand that load is being increased, instead of having multiple copies of that, how about having a mission with a higher performance being replaced?
So you mean machines or pods?
Missions.
Okay.
So this is on the mission side.
Okay. Okay, I thought it's about the pods because VPA has its downtimes, right? So I was thinking how VPA can help the scaling.
So downtime is like when you'll be completely shifting it over, but we could do something called as A/B testing, where you could spin up the same environment and then push it across into this VPA, like the vertically scaled one, where everything is ready. So green-blue deployments you could do across in such way, so that once everything is ready, you'll start pushing it like canary, like 40% in your real-time environment, and then 20%, 60%. You could keep reducing that and pushing over to the next type of already developed environment. That's how you could push it across.